Hi everybody, in this video we're going to go over test number 3. So in question number 1, it says which statement justifies this construction? So in the construction, the side length of AB was copied to make BC and CA. Notice how the arcs are the same length as line segment AB. So the correct answer is choice 3, that all of the sides are equal to each other because the construction marks show that the side was copied to create congruent lengths. Although the others are true of equilateral triangles, since it says which statement justifies this construction, the answer is based on the construction, which would mean it's answer choice 3. The side was copied and used to create all of the lengths of the other sides. Okay, number 2. We know that this is 66, this is 18 degrees, and this is 24. We need to find the longest side of triangle ABD. So in this triangle over here, I'll highlight it for a second. In this triangle, we know two angles of the triangle, 18 and 24. Since all of the angles of a triangle add up to 180 degrees, we can add 18 and 24. We get 42, and we can subtract 42 from 180 to find the measurement of the missing angle, which is 138 degrees. Since this angle and the one next to it are supplementary, they form a linear pair. Together they make a straight angle. We can do 180 minus 138 to get the measurement of this angle, which is 42 degrees. Now, in this triangle over here, we have two angles. We have 66 degrees and 42 degrees. To find the missing angle of the triangle, since all the angles of a triangle add to 180, we can do 66 plus 42. That's 108. And we can subtract from 180, and that gives us 72. The longest side of a triangle is across from the largest angle. So in triangle ABD, we have a 66-degree angle, a 72-degree angle, and a 42-degree angle. The largest angle is the 72-degree angle, so the largest side is across from the largest angle, and that would be side AB. In question 3, we want a line parallel to the given line. So the given line is negative 2x plus 3y is equal to negative 4. If we solve for y to clearly see what the slope is, we can add 2x to both sides. 3y is equal to 2x minus 4. Divide everything by 3. We have y equals 2/3 x minus 4 over 3. So the slope is 2 over 3. Since we want the line to pass through the point 1, 3, using point slope form, which is y minus y1 equals m, x minus x1, I can plug in. Y minus the y coordinate of the point that we're using is 3. The slope of the parallel line is 2 over 3. And the x coordinate of the point that we're using is 1. So that is answer choice number 2. For number 4, this is the construction of an altitude. You can review your constructions, but this is for sure the construction of an altitude. It's a perpendicular line. It is for sure not a bisector or a median. And the reason for that is because it doesn't pass through a midpoint. It doesn't cut in half. This point is not the midpoint of AB. So this can't be a bisector. This can't be a median. It's an altitude. All it does is form a right angle. It's a perpendicular line. Okay, We need to find the coordinates of the intersections of the medians. Medians connect midpoint to opposite vertex. So let me find the midpoint. 1, 2, 3, 4, 5, 6. So halfway is 3. 1, 2, 3. And let me connect midpoint to opposite vertex. Okay. Where would the midpoint be here? Let's see. A is -1, -2, -3, -4, -5, 2. And B is 1, 1, 2, 3, 4, 5. So the midpoint of AB would be -5 plus 1 over 2, comma 2 plus 5 over 2. That's 2, 7 over 2. 7 over 2 is about 3.5. It is 3.5. Oops, my bad. -2. That's -5 plus 1 is -4. So -2, 1, 2, 3.5. Oops. Connect midpoint to opposite vertex. And from just two medians, I can see the point where they intersect. That is the point -1, 2. You can do all three medians to see it clearer, but 2 is enough. Okay. We're told that FAD is parallel to EHC. FAB is 48 degrees, and ECB is 18 degrees. We actually did this question in class. Parallel lines cut by a transversal. You see the Z shape? Alternate interior angles. Inside the lines, different sides of the transversal. So alternate interior angles are congruent. We need to find this angle. So first I want to find this one. In this triangle, we have two angles, the 48-degree angle and the 18-degree angle. To find the missing angle of the triangle, since all angles of a triangle add to 180, I'm going to do 48 plus 18. That's 66. And I'm going to subtract 66 from 180. That's 114. Now this angle and the one next to it form a linear pair. They're supplementary. So to find the angle that we're looking for, angle ABC, I'm going to do 180 minus 114. And I get that it is 66 degrees. Okay, next question. So we have medians that intersect at point C. So we know that medians connect midpoint to opposite vertex, and we also know that the centroid splits each of the three medians in a 2:1 ratio. So CE is 5. Okay, so that's the shorter part of the median. So if that's the one part of the ratio, the two part of the ratio would be double that, which would be 10. YF is 21. So YF is this whole median here. We know the whole median is 21. Here's the two part of the ratio, and here's the one part of the ratio. So the two part of the ratio plus the one part of the ratio together makes 21. So we have 3x is equal to 21. X equals to 7. So the shorter part, the one part of the ratio would be 7. And then finally, xz is 15. 15. Since a median connects midpoint to vertex, this is the midpoint, F is the midpoint of side XZ, which means it cuts it into two equal parts. So each part is an equal half is 7.5. So the perimeter of triangle CFX would be the 7 side plus the 10 side plus the 7.5 side, which is 24.5. Okay. In this triangle over here, angle FEC, that's this whole angle here, is 84 degrees. And angle ECF, this whole angle here, is 28 degrees. We also know that point B is the incenter. That is the point where the angle bisectors of a triangle meet. So since these are all angle bisectors, they're cutting the angles in half. So this is 84, but half of it is 42 degrees. We want to find angle BRC, this angle right here. So that angle is located inside of this triangle. We have a 42-degree angle, we have a 28-degree angle, and we need to find the last angle. All we need to do is add up the two other angles, 42 and 28. So let me do that. 42 plus 28 is 70. And then we just need to subtract from 180 since all of the angles of a triangle add to 180. And we get 110 degrees for the measure of angle BRC. For this next question, it's asking us to write the equation of the perpendicular bisector of the given line segment that I just graphed. So the perpendicular part means opposite reciprocal slopes. Perpendicular lines have opposite reciprocal slopes. So we can do the slope formula for the line segment that we have. That's y2 minus y1 over x2 minus x1. So that is 5 minus negative 1 over 3 minus 3. That is 6 over 0. That's an undefined slope. So the opposite reciprocal would be negative 0 over 6, which is just 0. Okay. Not only is it the perpendicular line, it's also a bisector of this line segment. So that means it passes through the midpoint of this line segment. To easily find the midpoint, I can do the midpoint formula, which is the average of the x coordinates, comma, the average of the y coordinates. So that would be 3 plus 3 over 2, negative 1 plus 5 over 2. And that would be 6 over 2, which is 3, 4 over 2, which is 2. Since the slope is 0 and the midpoint that the bisector needs to pass through is the point 3, 2, we can write the equation of the line in point slope form. Y minus y1 equals to m x minus x1. Y minus the y coordinate of the point that we're using is 2. The slope is 0. And the x coordinate of the point that we're using is 3. If you did take a second and solve for y, you would get y is equal to 2, but this is a perfectly full credit response, perfectly complete response. And y equal 2 is a horizontal line, just like this line over here. This is the line y equals 2. Okay. Finally, constructing perpendicular bisectors. Let me get my compass. So I'm going to go to one side. I'll just go to the hypotenuse first. I'm going to go onto one endpoint, and I'm going to open up so I'm more than halfway down that line segment. And all I'm going to do is make a big arc below and above. I'm going to keep the same distance on my compass, go over to the other endpoint, and I'm going to make the same arc. And that's one perpendicular bisector. Oops. Once I draw a line through my intersection points with my straight edge. Okay, now we just have to do one more perpendicular bisector to any of the other sides. So I guess I'll just do the base of the triangle, the bottom. So I'm just going to put my endpoint, my compass point on one of the endpoints. I'm going to open up to more than halfway down, but the exact distance doesn't matter. Oh no. We choose a different color. Okay, I'm going to make an arc below and an arc above. Then I'm going to pick up my compass and move over to the endpoint of the other side. And I'm going to make the same arc using the same compass distance. Now that I have a top and a bottom intersection point, I'm going to connect right through. So the intersection point of my perpendicular bisectors is this point right over here. It says to label it point P. And notice how point P is on the triangle. The intersection of the perpendicular bisectors of right triangles should be on the right triangle. We talked about how the circumcenter, the point where the perpendicular bisectors meet, should be on the triangle for a right triangle. And finally, we need to construct the orthocenter of the triangle for the extra credit question. So the orthocenter is where the altitudes of the triangle meet. So we're going to be constructing perpendicular lines through the opposite vertex. So first I'll do the altitude to this side. So it's going to pass through this vertex. So I'm going to put my compass point on the opposite vertex from the side that I want it to be drawn to. I'm going to open my compass. It doesn't matter how much. The only thing that matters is that I make an arc that intersects the line segment in two spots. Once I have those two intersection points, I'm going to take my compass. I'm going to go over to one of those intersection points. And what I'm going to do is I'm just going to make an arc. Then I'm going to pick up my compass, keeping the same distance, and go over to that other intersection point and make the same arc using the same length. From that intersection point to the opposite vertex, oops, let me draw that again. From my intersection point, oh no, it's not allowing me to go right through the opposite vertex. This computer is very, very annoying. There we go. It's as best as I can get it. It does form a right angle with the side of the triangle that's drawn to. We do need to do it for one other side. We need to make an altitude to construct the orthocenter. So I'll do to this side. So that means our compass point needs to be on the opposite vertex. So I'm going to make an arc. Once again, it doesn't matter the length of the arc. Oops. I think my arc needs to be a little bit bigger. Too big. Okay. I'm just going to extend this side of the triangle slightly. And now I see two intersection points. Ooh, oh no, this computer is so annoying. I see the intersection point here on this side and the intersection point here on the same side of the triangle. I'm going to put my compass on one of those intersection points and I'm just going to make an arc. Then using the same distance, oops, I'm going to pick up my compass and move it to the other intersection point. And I'm going to make the same arc. Through that intersection point to the opposite vertex, I'm going to draw my altitude. And notice how my altitude is perpendicular to the side of the triangle. So here's my orthocenter, the intersection of the altitudes. And for an acute triangle like this one, it should definitely be inside the triangle.